If V is the volume of a cube with edge length x, and the cube expands as time passes, how do I find dV dt in terms of dx dt? So we've got a couple of things we have to figure out. First thing we have to figure out is how are we going to find these dV dt and dx dt? These are implicit derivatives. So when we think back to initial derivatives, if I gave you something like this, and I asked you to find the first derivative, because these variables match, we just do 2x. 2 comes to the front, we subtract 1, we've got our answer. Well, what happens when we get a problem where they don't match? So if I'm doing first derivative with respect to time of x squared, now our variables don't match. So in this case, we still take the derivative like normal. I'll still get 2x. But the problem here is because these variables don't match, I end up with an implicit piece of dx dt. Now this is true anytime that the variables don't match. And so we're going to have to keep that in mind as we go forward with this problem. Okay, so very first thing I would recommend for a problem like this is to start off with a picture. So we're going to go ahead and draw a picture of this cube. And again, it doesn't have to be perfect. We just need to make sure we have the general idea of what this cube looks like. And we know that the side lengths for this cube are x. Okay, so we have an x by x by x. Okay, so we've drawn our picture and we've labeled it. Second thing I want to do with this now is I want to go ahead and give a formula that goes along with this. So the volume of a cube is x cubed. Okay, length times width times height. All right, so now we have our formula. And now what it's asking us to do is find this first derivative with respect to time. So I'm going to go ahead and add in d dt on both sides. So I'm going to take the derivative with respect to time. So first thing we want to think about then is what would be the derivative of a variable? Well, that would just be 1. But because these letters don't match, we get dv dt. What would be the derivative of x cubed? Well, that would give us 3x squared. But again, because these letters don't match, we end up with dx dt. All right, so the question then is, how do I find the volume or the dV dt, the change in the volume with respect to dx dt? Well, we can just clean this up a little bit and just rewrite this then as dV dt. We don't need the 1 anymore. Is 3x squared dx dt. And we've now solved this problem.